Okay, now we're going to talk about graphing log functions. But let's look at all the components of a log function first. But even before that, let's look at what a log function looks like. Okay. Okay, a log function, uh, the basic, the most basic log function looks like this. It's the inverse of a exponential function. Okay, I just drew it in very light blue what a basic exponential function looks like. And you can see that it's kind of a mirror image, but a mirror image across the diagonal, right? They kind of like are flips of each other. The thing you have to remember is that whereas a exponential function had a horizontal asymptote right here, unless it got raised or lowered, the logarithmic function is going to have a vertical asymptote right here. Okay, you can see it's kind of like you kind of twisted it, right, from this to there. This vertical asymptote is very important as a marker for whether you're graphing it right. Okay, and where you get the vertical asymptote out of the function is a little tricky, but we'll explain that. So this is what it essentially looks like. The range of a log function goes from negative infinity way below to positive infinity way above. This will never stop going up. This will never stop going down. Okay, but the domain is not negative infinity to infinity. In fact, the logarithmic function is either on one side of the asymptote or the other. Happens to be on this side of your vertical asymptote. So it's going to show up in one place, and it just will not exist on the other side of that asymptote. Okay, so let's pick apart the parts of the function. This is outside the function. So is this. So this you could call, it's, I think outside the function is vertical. This is a vertical stretch, just like before, or reflection. So when you see this A, if the A is negative, okay, instead of going up, it's going to go down. It'll be kind of an upside down log looking thing. Okay, so that's the effect of A. The D is, as usual, vertical shift. But let me be honest with you, it's hard to see that. If you're taking something that goes from negative infinity below and positive infinity above, and you're shifting that up or down, it's really hard to see exactly how much that affects the thing, because it's already like a long up to down string. And so this is, hard to see. And the only time you're really going to know the effect of the A, where this becomes obvious is when it reflects, because it'll change the direction of whether it's going up over time or going down. But it still goes from negative infinity to infinity, either way. But a reflection is a little easier. A stretch is going to be very hard because this thing is already vertical. But here, of course, and this is the base of the log. But here is where a lot of what you want to see is going to happen. Here is where you're going to find the vertical asymptote. And in order to tell you how to find the vertical asymptote, I have to give this a name. I've been avoiding doing that. And if you Google this, there are lots of different names that the inside of the log is called. I'm not going to say inside. I'm going to use this weird word, argument. Okay, but this is very common math jargon for this part of the log, the argument. Okay, the vertical asymptote is the what x makes the argument 0. Okay, that's why it's an asymptote. Okay, that's why it should be a kind of a dotted line that says this function may not touch that value of x. Okay, because it's illegal. We talked before about how this is impossible. 2 to what power? On God's earth, what power can you assign to a 2 that will cause it to be 0? It does not exist. And that's why you have this border that is like a wall that x may not touch. Okay? So that's the theory. Let's put it into action. Okay. First thing that we're going to do is determine the asymptote. And let's just be really clear, for every log function, the asymptote is absolutely vertical. So as we just said, we will make the vertical asymptote hit x equals what makes the argument 0. There it is. Okay, that is the impossible. Oh, somehow we already are at 0. At 2 is what I meant. X equals 2. All right, so this is where our vertical asymptote is going to go. That's kind of one of the most important things that you got to get right. The next is we are going to play those 2 tricks. One, we're going to make the argument of the log just like we were doing it with the exponent, but now we're focusing on the argument of the log. We're going to make it the same as the base. What's the base? 3. 3 is the base. So if the argument of the log is going to be the same as the base, then x must equal 5. Right? And if x equals 5, and we plug that in, we're getting log base 3 of, well, 5 minus 2 is 3, minus 2. That's our y. Well, log base 3 of 3, what is this? It's 1. Same base. Base the same as the argument. 1 minus 2. So our y is going to be -1. So let's plot that. So we got 5, -1. All right. Okay, our next trick we're going to play is we're going to make the argument equal 1. Okay, that has an analog in the exponent world, but you'll see why we want to play that trick. In order to make the argument of the log 1, x needs to be 3. Okay, that way, when we plug 3 in for x, we're saying our y is log base 3 of 1 minus 2. Well, what is log base 3 of 1? In fact, what is log base anything of 1? We talked about that before. Log base of anything of 1, what do we take the base to in order to make the result 1? What exponent is that? It's 0. So we've effectively just made this into a 0. 0 minus 2 is our y. Y, therefore, is negative 2. So we're going to plot our next point right here. Okay, bring this 3 to negative 2. So in terms of checking whether this is the right shape, I mean, the only thing that I can think of that comes to mind is to make sure that we're on the right side of the asymptote. And you'll see in the next example when you'll end up on this side of the vertical asymptote. But here, and it's really because there's nothing that makes this x negative. You will see in a future example, the argument may say negative x plus 1, in which case there is a horizontal reflection that moves the graph of the log from here to here, okay? But we don't have that. So this is pointing in the right direction. Furthermore, whatever coefficient is here, I mean, you can call it positive 1. It being positive, this is ascending, okay? If this were negative, if this factor here in front of the log were negative, it would be descending, okay? But based on this analysis, I think it checks out, so I think we have a good shot. Okay, let's try this one. This has a couple interesting things going on. You can see right off the bat, we have an a, traditionally this coefficient is called a, that's negative. Oh, and we have a modifier to the x that's negative. So this is going to be horizontal reflection. You know what I know right off the bat? Of course, there's going to be a vertical asymptote, but our graph is going to be on this side of the vertical asymptote. Furthermore, instead of ascending like it normally does, I predict it will descend on this side of the vertical asymptote, because this is a vertical reflection. And the fact that it's on this side of the asymptote is the horizontal reflection part. So let's do first things first. We're going to put in the vertical asymptote. That's the first and most important thing. Vertical. Now, how do we find the vertical asymptote? We make whatever x makes the argument 0. So argument equals 0. Okay. X must be, now watch out, it's negative x here. I think we need that x to be negative 4, so that negative x is positive 4 minus 4 equals 0. Okay? This is our VA. Okay. Next, we want the argument to be 2, because that's the base. Okay? What x is going to help us accomplish that goal? I'm I'm going to say -6, because -6 is +6 minus 4 equals 2. Okay, so now we're talking about negative, oops, sorry, that's a weird thing. -3 times log base 2 of 2, thanks to our x being -6, minus 8. Well, that translates that to -3 times 1 minus 8. -3 minus 8, that's our y, equals -11. So, okay, -6, comma, -11 is, here's -6. Drop that down to -11. All right, first point accomplished. Next, we need our argument to be 1. That way we can just zero out the log portion of this function. So to do that, I would like my x to be -5. That way, -5 minus 4 is going to be 1. So when I do that, it's going to be -3 log base 2 of 1 minus 8. That's going to be my y. Well, the nice thing about this is that this goes away. That's 0. -3 times 0 is 0. 0 minus 8 is, well, our y is -8. So we want to plot this point next. So this is what we predicted. This is what we predicted. We said it was going to be the graph was going to be on this side of the vertical asymptote, and it is. Plus, we said instead of rising, it was going to, well, maybe that's confusing language. It's descending in the opposite direction. If it had reflected without this, if that had been positive, a reflection, a horizontal reflection would look like that. It would look like that. But because of this vertical reflection, this is a horizontal reflection, okay? That's a horizontal reflection. But a vertical reflection both does this and this, okay? And I am admittedly moving from right to left. But this does match the shape that we were expecting based on this reflection and this, whoops, this reflection.